my team members are Daniel, Ram, Manasik, and I'm Sinda. So we're just going to talk about our solution, which is visualizing energy flows for the ACE building. So this is just like a rough outline of how this presentation is going to go. We'll first talk about the overarching problem statement, and then we're going to talk about small objectives that we have accomplished under the overall problem statement. Daniel is going to talk about our solution, give a demonstration of what it looks like and how a user would interact with it. And then we can take questions from everyone. So the problem statement was, we have three subparts in the problem statement. We have, our solution is based on the new building in campus that is going to be constructed. It's called the ACE building. The assumption is that this building is going to have solar panels, batteries, and is going to be part of a new energy sharing technology with its neighboring buildings. The building is not going to take energy from the main electricity grid. It's going to produce its own electricity or energy with the solar panels, and also collaborate with its neighboring buildings to take energy from them if it requires it, using the ABB energy management system. So our task is to help users or visitors to the building visualize this energy sharing in a very simplified manner so that they understand what's going on behind the scenes. And also we have an interface for the operators or administrators, which takes in real-time data via APIs like the weather and helps those operators identify which building is the most suitable to take energy from at that moment. So these are some of the smaller subtasks under our overall problem statement. The first one is to simplify. So there was a lot of emphasis on how can we make this energy sharing technology visual, interactive, and easy to understand for any common visitor just walking into the building. The second one was support. So we have operators and login for like the building administrators, where they can view the kilowatt hours produced by the neighboring buildings, the weather, real-time weather data, and they can make decisions on how to route energy flows between buildings. So we have granular data. We have also application metrics, that is the CPU utilization, of website performance, response times, all of that. That is like a separate interface that we built. We have the login credential protected portal for operators that is not accessible to the visitors. So we are trying to be a friendly face for users walking into the building so that they understand what's happening, and just very bare bones, high level for them as well. And this is based on the actual electric grid of the campus that we have. And now Daniel is going to talk about our solution in more detail.
We have different interfaces. The first one is the visitor. It's like the common person that enters the building, that needs to have a really pedagogical way to show them like how is the energy obtained, where is the route that it's coming, if it's getting 100% by the building, or if it's getting help from one of the other neighboring buildings. So our main proposal with this was make it very simple. A simplified flow description with an audiovisual guide. It has voiceover explaining the visitor where is like this energy coming from, how is like the technology that is being used, what is like the system thinking or processing. And it's right now we don't have real-time measures because the building is being constructed, and we need data from solar panels and smart meters. But the idea is to be able to integrate it with real-time measures and energy flows that is going to get directly from the solar panel system and the smart meters in every building from the campus. Then we have another interface, that is the operator interface. So right now, as I was explaining, it's based on a simulation, but it's supposed to give the real-time measurements. So it's going to say, hey, we have Q buildings, A, B, C, D, E, F, and Q. So the building A, it's producing this much kilowatts per hour. It's consuming this much kilowatt per hour. And we have like a surplus of energy. And then the system is going to make a ranking of it, and it's going to suggest to the operator, hey, you should take energy from this building because it fulfills the need of energy that you have right now, and it's the best one. according to one thing that I'm going to explain later. We have security. We have the operator interface. You need a login, so not everyone can enter the information about the whole campus, the whole electric information about the campus. Also, the information, we are a green program, so we care about the smart use of resources. So our application gives health checks, it shows how much resources it's using, the website's performance, so for the operator to check that if everything is performing according to normal values. And it's API enabled, so right now we are gathering weather information in real time. That is like the only real information that we can use at this point of the prototype. But the idea is to be able to integrate more services using APIs. For example, for the smart meters, for the solar panels, inverters, batteries, all technological devices that we can implement into this system to make it easier for the operators and also to show them to the users. Now we are going to show you a demo.
Okay, so now I'm going to show a short demo for our product. What you can see here is a user interface of the visitor website, the visitor interface. On this interface, we have like a weather hub for the user, and on the hub, based on the current temperature, wind speed, etc., we are going to give like a recommendation for the visitor, like should wear super warm clothes before going outside, etc. And here we have the electricity distribution map. This is how we are going to show.
Surplus energy from building A, building B, or building C. Here, building C appears to be the optimal energy source. Welcome to the ACE building. The future of our environment lies.
So that's the end of the visitor user interface. And as the operator or the admin of the project, we can sign in as like admin or operator here, and then he or she will be shown the operator hub. With this operator hub, for example, the building Q currently needs like some specific amount of kilowatts more to operate the whole building. So the system will recommend the user to take the energy from one of the following neighbors, like neighborhood building, and then based on these statistics, the admin or the operator will be like suggested to change the route of the electricity flow. For example, here, this is like a Celestial campus power supply diagram. So the admin can change the route. For example, like currently the system is suggesting to like receive the electricity from the building M. The admin can take the electricity from M to supply the energy to the Q building like this. So besides, we are giving, as Daniel said, we are giving some application metrics because we are like a group of members who care about the sustainability of our planet. So we provide the application metrics, and we provide some like resource consumption of our program, so that the admin or the app operator can modify some like a configuration of the program to suit with the sustainability goal. For example, as you can see here, it's like flash memory or RAM consumption, etc. So that's the end of the demo, and let's talk about the next part.
So to explain you a little bit like the thinking that we did behind all the design. The first part that you saw, that it was like welcome to the ACE building. Right now, it's hardwired to say that the C building is going to give the energy, but the idea is that it updates dynamically with the real building. So right now we said that it's A, but if in the future it's taken from the building F, that animation is going to say that it's taken from the building F and it's going to move from somewhere else. Just that with the limited time, we did like only one. This is the map that is going to show into the operator campus. This right here is very similar to the real campus, to the real map of the campus. These blue lines are the real electrical grids that are constructed, and this is where the Q building is going to be. And for our simulation, this is more or less like the mathematics behind the calculation that we said when we are going to suggest which building is going to get it. So what we did for simulation purposes, we calculated the roof area of each building using Google Maps. We have more or less a certain amount of kilowatts hour per square meter, that is 150. So we get like this capacity of solar energy. We are fetching from the API the percentage of clouds in the environment right now in Skellefteå. So that, for example, in this case, in this table, it's 75% of clouds. So that's going to affect the solar energy that we are producing. And we are also assuming that we are consuming 80% of that energy per building. So that gives us a surplus of energy or a difference of energy, where the system is going to search in this order. First the N, first the M, then F. This order was made calculating the distances between the Q building and the next building. For example, this is closer, the next one is this, the next one is this, to diminish the loss of the cables. And then in the end, for example, in this case, if the A building needs 15 kilowatts per hour, so we are going to choose the building CD, that is the one that fulfills its necessity. That's like the logic behind the suggestion. Thank you.
Sure. The most obvious one. Why the Dino?
That's just because I like dinosaurs. Other reasons.
It's really cute. So I'm wondering, so the task was really, because we have an urgent need for the project, which looking into this, actually doing in real life what you're suggesting, to take the power for the Q building from the other buildings. And we have a need in the project to get the visualization primarily on a paper, like 2D. I really enjoyed your more like digital versions of it. But if I would just supply with the project with a 2D print, which one should I show the project?
Sorry, we didn't. Can you like repeat the question again?
Yeah, I'm looking for a 2D, like a.
Oh,
yeah,
like
just
like this one, for example.
Yeah, exactly. Do you think this is the best representation for me to show the project?
For so is it depends on who the end user is. If it's going to be for like layman, then probably the visitor interface, the depiction. If you want to get slightly more technical, so here we were going to have like kilowatt readings and everything. Then it depends on who's going to be looking at the visualization.
So for example, with the operator view, we have, at the beginning, we have the whole grid, where he can see like how is interconnected everything. And if he, for example, he can choose from wherever buildings, for example, if he's going to take it from M, this is the real representation of the whole flow of electricity according to the electrical 2D maps that we were given. But we can make it more technical if that's needed. Like we can show the cables that are going, the...
I think this is good enough.
Yeah, I
To be
mean,
honest.
we can make it as technical as it needs, but right now we are trying to make it more easy to understand. But yeah,
You showed the map earlier where you could actually see the flow in which direction it's going. It was in one of the pictures. Because it's very hard to see which way it's going with this, the yellow.
oh yeah.
Yeah. Yeah, it was in the movie, right? Because this one I think was really clear.
Yeah.
Yeah, I like that one a lot. And also, did you consider the energy consumption within the building? How to visualize that? I gave you some information about the zero sun building.
Yeah, I mean, the idea is that right now, that's why we said that it was API enabled, because we know that we need, I mean, we can still do simulations about it, but we need to fetch real data from the solar panels, and we need to fetch real data from the smart meters inside the building. So at this point,
but
we
I was
just...
thinking how to visualize both inside the building and outside, because you would have like powering it from battery or...
We did like in this part like a little prototype representation with like batteries and the consumption of the building, that it can be of course made into a huge dashboard, but more or less
Yeah,
this is what...
understand. It is just, it's both, it will be powered from the surrounding buildings. I think you showed that in a really good way. And that's very good, very good. I was just thinking whether you have some sort of idea how it would be possible to visualize the energy consumption within the building in the same setup.
Okay.
Because we need to do both.
Yeah.
We will have a solar panel roof on the new building and we'll possibly have a battery in the cellar.
Yeah.
That can be done.
That can be done.
Yeah.
Yeah, great. Good. What did you think was most challenging with this task?
Make it easy.
Yeah,
Make it
simplifying
easy and make it simple, because
User-friendly.
and user-friendly, because for example all of us have technical backgrounds, so for us some things are given and we understand some language, but this was supposed to be given to a visitor who has no idea about electrical stuff and solar energy and loads and that. So we tried to make it also, like the idea of the dinosaurs was to make it more friendly and engaging and not just a boring electrical thing.
Perfect. Thank you. What do you think would be the next step?
Fetching data,
Yeah.
fetching real data from solar panels and smart meters.
And
Yeah.
also
So we have managed to fetch the data for the weather so far, so you
Yeah.
know it's working. So you
Ah,
can
yeah.
just add solar panels and smart meters.
Yeah, that's why we put the weather. It's not really relevant, but it's just to show that the system is able to fetch data in real time.
Yeah, that's excellent. Would it be possible for you to present this for our project?
Yeah, yeah,
Yeah,
definitely.
great.
Yeah.
Leif, is that okay with you?
Oh yes, of course.
Yeah?
That's
Because
okay.
I think I would be really nice to present this to our partners in this, which is LTU, Sara, I forget her name. She's newly installed professor at Luleå, Sara Rönnberg. We also have Carl Andersson, we have Skellefteå Kraft, Skellefteå kommun, and they will be in this project. So it would be very, very nice to see what they think of this visualization.
A question from me. Have you considered doing any predictive analysis of the energy demand of the buildings? Since you're bringing in weather and so on, it could be good to see if we predict that 24 hours or so. Would that be interesting? You think?
Yeah.
Actually, yeah, and well, we didn't present ourselves. I don't know if you know about it, but we are Gen students. We are doing a master's program in green computing and cloud networking. And through all of our knowledge, we have been seeing different, we are getting different knowledge. For example, last semester we were in the UK and we did some machine learning, deep learning, and we were like in our projects predicting some values from some stuff. For example, myself, I was doing research on energy consumption in Colombia, and I was able to do an algorithm to predict some energy consumption for the next month. So it can be implemented, it can be integrated. Yeah.
It should probably help control algorithms also
Yeah.
to distribute energy in a nicer way.
We just need historical data first to be able to train the system, but yeah, it can be done.
Nice. A big hand from me. Welcome. Thanks a lot.
Just for your information, Marie, Radio Västerbotten will introduce this group in their their broadcast around. They will call me 11:45 and make an interview at 7:15 in some broadcast today.
Perfect. Well deserved. Best of luck.
Thank you.
Thanks a lot. I keep in touch.
Yeah.